So let's take a look at how we do this skill with a standard form quadratic. So here we'll have negative 2x, that 15 is plus 5, and the 13 is just plus 3. So now we want to be able to sketch accurately the expression y is equal to negative 2 multiplied by x squared plus 5x plus 3. So the first thing that we can do when we're doing this is get a good visualization. And the c value there actually gives us directly the y-intercept. So we can go ahead and put that onto our graph. Plus 3 there. There's the point 0, 3. And then we also know that the a value here gives us our direction of opening. So this one is opening downwards. But then this expression here, 5x plus 3, is going to actually, if we graph that as a line, notice that that's mx plus b. Let's go ahead and put that in. The line 5x plus 3 has a very steep slope. It looks something like this and something like this. This quadratic is actually going to come up, kiss that line, and curve away from it. So this expression is actually really useful to help us visualize this quadratic just by looking at a, b, and c. If you can visualize that line, y is equal to 5x plus 3, then you can tell that this quadratic, which is opening downwards, looks something like this and like this. It's going to come up, kiss that line, and then curve away from it again. So our vertex is going to be somewhere over here. Now let's go ahead and find the roots and the vertex using the quadratic formula or factoring. In this case, actually this is a factorable quadratic, but we're going to use the quadratic formula anyway, just to get some practice with that. So let's go. So first step is to be very clear. Our a is -2, our b is 5, and our c is 3. And then we're going to write out our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But I like to think about it this way, split up a little bit. And that's something that we can do. We're allowed to do that. If we have like a fraction like 3 plus 5 on 7, that's the same thing as 3 sevenths plus 5 sevenths. If you have a plus b on c, it's like a and b are both being divided by c. So writing it this way or this way is really just a question of fluency. Can you change from one equivalent form to another when it suits you? And in this case, it suits us because it's going to allow us to get a really good visualization of this thing. Why is that? Well, let's put in our values. So x is equal to negative 5 on 2a, which is negative 4. That's 2 times negative 2. And negative 5 on 4 is the same thing as positive 5 on 4. This actually gives us the equation of the axis of symmetry. Our quadratic has a vertex at 5 on 4. So that's this value here. And now we can go ahead and figure out around that axis of symmetry, how much do we go this way? How much do we go that way? That's determined by this part of the quadratic formula, the part that we're either adding or subtracting. So that's visually where here's your axis of symmetry, and here's how much your roots are stretched around the axis of symmetry. So we can go ahead and write this as plus or minus, put this on negative 4, okay, b squared minus 4ac. So b squared is 25, and negative 4 times negative 2 is positive 8. Positive 8 times 3 is 24. So 25 plus 24 gives us 49. So this is x is equal to negative 5 plus or minus the square root of 49 on negative 4. Now we'll put it back together now to find the roots. Okay, x is equal to negative 5 plus or minus, well, square root of 49. We can do that. That's 7 all on negative 4. Okay, and now negative 5 plus 7. If we do plus, that would be 2 on negative 4. But if we did minus, that would be negative 12 on negative 4. which are other ways of saying 1/2, but that one's negative, or 3, and that one's positive. So those are our roots. This is negative 1/2, 0 is that root, and this root here is at 3, 0. Okay, so put those down, 3, 0, and negative 1/2, 0. Last thing to find is the vertex. Great thing about that is we already know the x value. So you don't need to complete the square to find the y value. You can just sub and solve. So let's get ourselves some space where we can do that. I'm just going to put this out over here. Put my paper underneath where I'm working and copy that out. Y is equal to negative 2x squared plus 5x plus 3. And I know that x is equal to 5 on 4. So now we just sub and solve. Five on 4 squared is 25 on 16. 25 on 16 times minus 2 is y is equal to minus 25 on 8. 5 times 5 on 4 is plus 25 on 4 plus 3. So that's y is equal to positive 25 on 8 plus 24 on 8. Isn't that cute? And you're going to notice a lot of these kind of patterns in the things you find. Y is equal to 49 on 8. This is the y value of the vertex. 49 on 8 is the same thing as 6 and 1/8. So let's go ahead and put that in 5 on 4, 6 and 1/8. Put that onto our sketch. And then, of course, we'll want to check that in Desmos to see how well we've done. That's why that's happening. I'll know now. I'll never do that again. Okay, so minus 2x squared plus 5x plus, where were we? Plus 3. Okay, there. Send it back home. All right, so there is our sketch. If we take a look at this point, 6.125 is exactly 6 1/8. 5/4 is 1 1/4. There's our y-intercept. There's that one. There's that one. That all matches. That's great. And then we can also visualize 5x plus 3, that line, and notice it has this property that we were describing that allows us to visualize the quadratic very quickly and really build our math fluency for working with standard form quadratics. So working with your quadratics to build your fluency is just fantastic because it allows you to work both visually on something like this right away when you know how to visualize factored form, vertex form, and standard form quadratics, and then quickly do some algebra to find all of these interesting points that allow us to sketch that very effectively and put it together just right. All right. If you need any more help working on your quadratics, talk to your tutors, talk to your teachers. Otherwise, I salute you for showing up for your learning and building your math fluency. Bye for now.